Okay, so today's lesson is just going to be a short little overview, some things about exponents and radicals. So exponents are a shortcut for multiplication, and that may be something that you already know that you learned last year. Sorry, I can't write and talk at the same time. So what I mean by that is if we have something like, for example, so we'll put a little example here in our notes. If we have like 5 to the third power, the 5 is the base. That's the number that's being multiplied. And as you may know, 3 is the exponent. And 5 to the third would be the same as saying like 5 times 5 times 5. Okay, or if we said, here's another really good example to put in your notes. If we had like 2x to the fourth, now notice the 4 is only on the x. That 4 exponent is only on the x. So this means 2 times, it's the x that's the base, and that's what's being repeated. Multiplication 4 times. So that's 2 times x times x times x times x. All right, that's kind of our basic understanding of exponents there. Okay, now radicals, and when I say radicals, I'm talking about square roots or cube roots. So this whole term radical is anything that's a root. So like that's a square root that secretly there's like a little 2 there, but we normally don't write the 2 for square roots. Or we could have cube roots where you put a little 3 there. Or they just keep going, right? You can have fourth roots, so on and so forth. Radicals are the inverse of exponents. So what that means is radicals and exponents are opposite of one another. The same way that you undo addition with subtraction, those are opposites. Multiplication and division are opposites. Exponents and radicals are also opposite operations. They're inverse operations. So to simplify radicals, that's what we're going to talk about next, is simplifying radicals. To do that, we have to break the numbers that were given down. So we're going to have to break down into prime factors. And you may remember those words and not really know exactly what they mean. So prime are numbers that can't be broken down any further using multiplication. For example, 8 is not prime because 8 I can break down to be 2 and 4. All right? An example of something that is prime would be like 5. I can't break 5 down any other way except for to get 1 and 5. And when we say break down prime factors, you may have noticed what I was doing here, but in general, that means we're going to be doing factor trees. So I'm going to show you just a few examples, and then we're going to practice this more and talk about it more in class tomorrow. All right, so this question, something like this would be asking us to simplify the square root of 28. Well, the first thing I need to do is break 28 down into all of its different pieces. All right, so 28, if I break that down, I know that's an even number, so I can divide 2 into that. So 2 and 14. All right, 2 is prime, so I'm going to like circle it so I know I can't break it down anymore. 14 I can break down also. 14 breaks down into 2 and 7. Okay, so that means the square root of 28 is the same thing as saying the square root of 2 times 2 times 7. Notice that the square root symbol is still there. I broke the 28 down, and then I just put all these 3 prime numbers inside there. If you used a calculator to check, 2 times 2 times 7 would give you 28. Now, because this is square root, remember on the last slide I told you that there was a secret little 2 right here. So because it's a 2, I need pairs to pull out whole numbers. So for square roots, you probably need to put a little star. I'm going to write that note down for you. Okay, for square roots, written either way, you need pairs to pull out whole numbers. So in this example at the top, I have a pair of 2s, which is going to pull out a whole number. Unfortunately, the 7 doesn't have any other pair, any other 7 to go with. So the final answer, if we were to rewrite this, would be a whole number 2 on the outside, because it's allowed to come out of the square root of 7. All right, that's the same thing as the square root of 28. Let's try another one and see if that makes sense one more time. All right, this time we need to break down 54. So I'm going to go ahead and make my tree. 54, the first thing that comes to my mind is 6 and 9. It doesn't matter where I'm starting, we're going to get the same numbers in the end. So 6 does break down. 6 breaks down to 2 times 3, and neither of those break down, so I'm going to circle them so I don't lose them. 9 breaks down into 3 times 3. Okay, so I'm going to take that and rewrite what I have. I've now got the square root of 2 times 3 times 3 times 3. Again, this is a square root problem. I know that because there's no number written out here, so I know to assume that's a 2. And for square roots, I need pairs. So I have a pair of 3s. And then this 2 doesn't have anything it can pair with. That 3 doesn't have anything it can pair with, so it has to stay there. And this pair of 3s comes out to make a whole number. So when it comes out, there's no multiplication there, it just comes out as a whole number, which means my answer is going to be the whole number 3, and then square root 2 times 3 left on the inside. Now there's actually one more thing we can do to simplify that. We can multiply this 2 times 3 on the inside, which means my final answer is really going to be 3 square root of 6. Okay, one more example. All right, this time they're asking us to solve for a cube root. We're still going to start the same. We're going to break down. So I see 8 and 10 is the easiest thing I see. 8 breaks down to be 2 and 4. 2 can't break down any further. 4 can break down again, 2 and 2. 10 can break down to be 2 and 5. All right, so this one's kind of got a lot of pieces going on. So I've got the cube root, 2, I count 4 2s, so 2 times 2 times 2 times 5. Now, the difference here is this says cube root. So for square roots, you needed pairs because the secret number was 2, right? Squared means like x to the second power. Cube root means the third power. All right, so that means I need 3, a group of 3, to make a whole number. To make a whole number. All right, so that means I need all 3 of these to make a whole number. So those 3 are going to make a whole number, and the other 2 and 5 are still stuck, which means I now have the cube root. Oh, I should have written the whole number 2 comes on the outside, and then I have the cube root of 2 times 5. And just like with the last one, I can simplify that 2 and 5 on the inside and go ahead and put them back together since they're not going to make a pair anyway, or a group. So that's going to be 2 and the cube root of 10. That's how we would write that and how we would say that.